Ladies and gentlemen, thank you for standing by. Welcome to the webinar, Every Blast Counts, how the ProVision drill system can help you meet or exceed your drill and blast design goals. During the presentation, all participants will be in a listen-only mode. If you would like to ask a question during the presentation, please use the chat feature located in the lower left corner of your screen. As a reminder, this conference is being recorded Wednesday, June 4th, 2014. I would now like to turn the conference over to Eric Anderson with Modular Mining. Please go ahead, sir.
Thank you very much. I'd like to welcome and say thanks to those of you who've joined us today. It's our distinct pleasure to have you with us. We know that your time is important to you and appreciate you taking the 30 or so minutes to join us. Today's presentation will focus on our ProVision drill system, the machine guidance system for drills. It's presented by William Nassauer, better known to us here at Modular as Bill. Bill is our product manager for safety systems and machine guidance. Bill has over a decade of experience in the mining sector and leads our strategy and development of our safety and productivity solutions. Bill, for those of you who don't know him, also has significant experience in project and account management, leading mining companies around the world. Bill also has an MBA from Columbia University and a BS from Industrial Engineering from the University of Arizona. Very quickly, my name is Eric Anderson. I work with the marketing team out of our corporate office in Tucson. My role here is to simply provide a brief company introduction and handle some of the administrative functions. As such, I'd like to remind you and encourage you to please ask questions. If you've got comments, please don't hesitate. To do either of those things, we ask that you please use the chat box on the left side of your screen. We'll do our best in the last 3 to 5 minutes at the end of the presentation to address your questions. If for whatever reason we can't get to them, we'll respond to you within approximately 48 hours. So, very quickly, just a little bit about Modular. For those of you who don't know, we are in our 35th year of business, and we thought it would be a good idea to provide an overview, maybe some historical background and associated data spanning the 35 years. So to be in business for 35 years, typically you need a goal or a vision. What is it you'd like to do as an organization? And for us, we have a simple vision, and it's depicted here on this slide. Simply put, it's to revolutionize the way the mining industry operates in real time. Put another way, it's our goal to provide your organization with the systems, the tools, the ability to optimize, refine, to become faster, more efficient, more productive, and to have a tangible impact on the bottom line to maximize profits. We're able to do that by offering a set of products, services, and solutions that span the major segments within the mining industry. So in this slide, we show just a snapshot of our primary products and then some of the, for lack of a better term, secondary products towards the bottom. Along the top, it's dispatch in our groundbreaking fleet management system. That's basically what started Modular. It was the first of its kind and remains the gold standard today. Machine guidance in our ProVision line. That's what we're here to talk about today. That's what Bill will go into some detail about. Maintenance is covered via our MineCare maintenance management solution. And we cover safety via the MineAlert software system. And together, or combined, they're packaged under the umbrella called IntelliMine, a single solution. Some of the ancillary pieces, the supporting infrastructure, etc., for us that's known as MasterLink, basically wireless components, ground stations, etc. We also have support and consulting services via the Modular Mining Services division. And those last two items are obviously handled out of our Tucson office, but also globally. In 35 years we've been in business, we've expanded to all of the major mining markets throughout the world. To put it another way, this is perhaps a overly marketing-esque, if you will, but we're on every continent except Antarctica. And I suspect once mining commences in Antarctica, we'll be there too. So I said early on that we've been in business for 35 years. In the 35 years, you've seen the products we've created. They're available today, and you see now our offices around the world. What have we done with those products and those offices? So we'd like to take just a couple minutes here, and then I'll hand it off to Bill, to talk about some of our achievements. So first, 35 years, I'm pretty sure if I can subtract adequately, that means 1979 is when we started. Shortly thereafter, in 1980, we launched Dispatch. That's the world's first computer-based mine optimization system. The next few slides here will go by decade. In the 1980s, we implemented the operator interface panel and RF signpost beacons, and the first Dispatch underground system was commissioned. In the 1990s, GSP modular ready interfaces were released, and today we have far and away the most interfaces on the market. Interfaces meaning that we integrate with varying equipment types. And field solutions with GPS technology. That was at the dawn of GPS. GPS is so ubiquitous today it hardly seems worth mentioning, but at that time it was rather substantial. And in the 2000s, we became part of Komatsu, one of the largest heavy equipment manufacturers in the world. We, of course, for those of you who follow some of the popular mine trade publications, you've probably read about this, but we co-developed with Komatsu the front-runner autonomous haulage system, and that may be on some of your sites there for those of you on this call. We expanded our OEM interfaces to over 100. Our mining services division was formed, and we were installed in our 200th mine. That brings us to today, and as I said, 35 years in business. We're now on our 6th generation of the Dispatch system. Recently, I believe it was February, earlier this year, regardless, we opened our brand new Research, Development, and Support Center here in Tucson, Arizona. So those are some of the achievements. We've many more, but just to keep it brief, we thought we would organize it by decade and show you something brief. What we haven't done is show you some of the results. We focused on products, global presence, etc. But here are some of the outcomes, the results of those products and those offices in our 35 years in business. And we've labeled them, you see the top of each box here in the next sequence, according to what we feel we've accomplished and established with our customers. And the first is trust. And we feel confident that we've established the trust of our customers because we're in 18 of the 20 largest mining companies in the world. Results. We've proven production at 240 plus mine sites. And production. Each of these follows a rather linear progression. And production, which equals in this case, these are some data that we surveyed via our internal resources and our customers. And so that number is right. 70 million tons of 70 billion tons of additional production due to our dispatch system. It's not often you say 70 billion. And finally, what matters most, savings. So with our solutions, we've saved our customers over $100 million in maintenance costs. We think that's substantial. And then finally, to segue into our topic today, ProVision. ProVision has been on the market for nearly 20 years. And in that time, we've provided integrations with heavy equipment like loaders, shovels, dozers, and of course drills, the topic of today's presentation. So without further ado, I would like to hand it over to Bill, who will go into more detail about machine guidance and specifically our drill system. Bill?
Yeah, okay. Thank you, Eric. So welcome everyone. So let's talk a little bit about machine guidance in general before jumping into the drill. You want to jump? Actually, I can manage this, can I? Okay. So yeah, we've already talked a little bit about our history, so I won't go too deep on this, but you can see how ProVision kind of starts for us back in the mid-1990s. We were pioneers in this area. We were the first to offer a shovel guidance system before it was actually called ProVision, and we were the first to use augmented GPS, which means GPS plus the Russian GLONASS satellite system. There are a couple notable points through this history. We added drills in '99, we added dozers in 2001, and so the product line continued to expand. In 2003, that was our first major system redesign, so you could kind of consider that the kickoff for ProVision 2, the second generation. That was Masterlink technology, and it was when we moved to Wi-Fi for higher speed communications and higher bandwidth. In 2009, we added the backhoe, so that kind of completed the product line that we have today. And in 2011, that was when we released ProVision 3. And so that's our new third generation platform. You can see the hardware on the lower right there using PTXs. The new system had a number of benefits and improvements for our customers over the years, among them shared digital terrain models, persistence on the screen if it were to be power cycled for all kinds of data that's for the operators currently working. And for the future, we're working on a lot of different things. These are just a couple of items. Next generation whole stratification. That's actually something that we're releasing now. We've got a third-party API for mine planning systems in order to work with different geology and the planning systems that you have on site to avoid doing flat file transfers between those systems. And we'll be working shortly on integrating our autonomous truck management system into ProVision for the future. So how does ProVision work in general? The concept of it is about all this information flow that you see here. It kind of starts with mine planning. All of the information from mine planning is input in through the Office application. So things like design surfaces, polygons for material boundaries, hazard locations, work limits. All of these things are put in and they're shared with the mobile applications in the field based on their positioning. So when they need a particular set of data, it's provided in real time over the network. And this feeds back into mine planning, where they're able to pull out this data and update their models or run reports, which are there's also a set of reports that are included in the system. So the point here is that the mine plan updates the work plan, and the work that's actually going on in the field comes back and continues to update the mine plan. So there's this circle of communication which is constantly going, right? So basically, a couple major points here for ProVision in general. We have the whole point is to have a universal mine plan that's communicated out to the field and managed in real time, and this helps to ensure high levels of precision, basically that the work is done according to the plan. Right? And the high precision itself is something that's used to help the operators increase ore recovery, maintain control of elevation as the machines are working, drill your holes accurately, and manage materials. Those are kind of the major functions of the system. And the system provides comprehensive reporting through dashboards and KPIs that are, and just reporting substructure which is available in the system in order to help you understand what your operators are actually doing out in the field. Okay, so let's talk about the drill now. So the drill is something that I mentioned ProVision 3 was released in 2011, but we've kind of been doing it in phases. We didn't release, it's a big job to migrate the entire, all the different machine types that we have, shovels, drills, dozers, loaders, and so forth, to ProVision 3 all at once. And so we kind of had a phased approach, and the drill is the part that we completed this year and released in February. So the drill system in ProVision 3 is relatively new. Now the purpose of it is essentially the same as it always was. So generally it's about allowing operators to drill precisely, showing them how to arrive at the holes and to measure the depth as they're drilling in order to improve efficiency of the drilling rig and meet the goals that have been established in the design of each hole pattern. The guidance is done through the application of high precision GPS or GNSS, which allows them to work during poor visibility and at night without the need to put stakes out in the field and to mark holes. At least that's what you should be working towards. And we have an optional drill hole stratification module, which I'll go into more detail on, which is meant to help optimize optimize your blast by understanding the geology in each particular area where the hole is drilling. And there's some big implications for this as far as saving on explosive use and your ability to crush. All right. So in terms of this kind of summarizes the list of benefits that the system provides. The biggest is real-time depth against the design. So basically, this is about better compliance to plan, making sure that the drill actually drills down to the depth for each hole, and we're able to measure that very precisely and communicate that to the operator so that they know as they're working how they're doing. High precision navigation is a major piece of that. The positional accuracy it can be as precise as 1 centimeter. It kind of depends a little bit on the conditions in the mine. The system is developed for the mining environment, and we have a lot of experience with this in our 35 years as far as making rugged equipment and being able to work in these conditions. Stratification, which, like I said, I'll go into a little bit more detail on, but we're able to use the sensors on the drill, either the OEM sensors or we can install our own sensors in order to get drilling energy per hole, and that can turn into actually recognition of the strata of the hole, the types of rock that you're drilling through, and help with optimizing your blasting. Accurate collar location, that's just about basically getting the hole exactly where it's supposed to be without needing to survey it and mark out in the field. And then reporting, right? With better data and better understanding of what you're doing, you're able to have better results. And so that's kind of a fundamental piece of the system, is providing that feedback and helping you understand how the operators are working. Here's kind of an example of what we're trying to avoid. I'm not sure what the circumstance was in this particular image, but you can kind of see two different patterns here, right? The holes were drilled kind of on one side in one way and on the other side in another way. The problem with this is this causes inconsistency in the spacing between the holes and can affect the quality of the blast, where you've got poor fragmentation or which then results in difficulty in actually extracting the material. So we want to avoid this. We want to actually have very precise hole placement and depth as well, so that these blasts are as efficient as possible. Now, optimal blasting performance. There's a number of, if we kind of look at this in terms of cost and different factors that affect cost. This chart shows basically, if you look, the x-axis from left to right is increasing fragmentation. So basically, if you were to blast the material such that the fragmentation is higher, the cost is on the y-axis, right? So you can see if you look at blasting cost, obviously that the cost goes up as you increase fragmentation because you're using more explosive, you're charging the holes, or maybe you're drilling more holes that are closer together. That does help your processing and your load and haul costs because, well, for load and haul, it's simply easier to get it out of the ground, right? When you've turned it into powder, it's pretty easy for the shovel to scoop it up. Processing cost at the plant usually drops as well to a point. But there's an overall point where, an optimum basically in the middle here, where the total cost is the lowest. So you don't want to go too far. And the question is, where is the sweet spot? Well, the sweet spot where you're blasting just enough to fragment sufficiently, and you're fragmenting just enough to make the extraction easier, easy enough for the shovel to get through, but you're using explosive in a proper way and not going too far cost-wise that way. So the point is to optimize total cost, and this is what the drill system using stratification can help you achieve. So as far as how stratification works, as we're drilling the hole, there's a lot of data that we can pull from the various sensors on the machine. Some of these sensors are part of some of the interfaces that we've developed over the years, which Eric mentioned earlier. We have a number of drill interfaces that currently exist for Atlas Copco, for Bucyrus and CAT and others. But generally, and it's a little bit different whether it's an electric or hydraulic drill, but you can see here we usually use RPM, pull down pressure, torque, and penetration rate. And by putting these factors together, we're able to calculate the drilling energy, right? So if you kind of look at this chart, it's kind of flipped on its side where top to bottom it's corresponding with the depth that the bit is at, and you can see the energy plotted where more to the right is higher. And depending on the geology at your mine, you can kind of define limits and understand that when the drilling energy is within a certain range, you're going to be drilling a certain type of material. And so this helps you identify exactly what it is that you're drilling through, right? It turns into a stratification, a profile for each hole that's gathered in real time and stored in the central database for you to use to basically analyze it, use as feedback in order to design a more efficient blast. So the benefits of proper drilling and blasting, you kind of fall into these major categories. Obviously, cost, like I said, is a big factor, and I showed you how that can be done in terms of improving fragmentation, improving load and haul efficiency, and helping at the crusher and at the mill. But there's also like a safety component. So if you're blasting properly, you're reducing the amount of rock fly and fewer misfires and so forth. Efficiency is higher, so scheduling and rework, and you're able to make better decisions about how you want to drill and how you want to do the next hole, and overall an increase in quality as far as better ore control and improved final shape of the pit, is because you want to drill down to exactly where the next bench is and not too far, or you don't want to leave a toe there that's going to cause problems for the shovel when it goes through the material. Right? So we've got a specific example of where this was applied. There was a case study that we did a few years ago. This was using stratification with our ProVision 2 system. You can see here where the focus in this particular case was improving efficiency at the crusher and reducing cost of drill and blast overall. And we looked at explosive consumption and before and after. Before, they were using ProVision and with stratification to try and manage this more closely, and after. And you can see the improvement is pretty dramatic. A 21.6% overall explosive consumption drop, and the costs at that site were reduced. It's close to $800,000 on an annual basis at that mine site, or at those mine sites. Right. So let me show you a little bit what the system actually looks like. Some examples of the mobile application. Like I said, the system is ProVision Drill is not new for us, but this generation is. So the screens have changed. We have a new user interface and a new design, and we're pretty proud of it. So this is what the cycle looks like. First of all, what you see here is the screen that the operator. Basically, I'll step through what the drill cycle looks like. Starting with this is navigating from hole to hole. So basically, as the machine is tramming, they finish drilling the hole, and they're working to get to the next one. They see a zoomed out view where all the holes are marked. You can see colored dots indicating the holes that were already drilled. The color kind of indicates the status of it. If they drilled it to target, or if they were a little over or under, the color is going to indicate that, just kind of as a visual indicator for how they're doing. As they get close to the hole, they get a zoomed in view so that they can fine tune their positioning in order to get right on top of it. In this particular example, they're still about 4 meters away, or 4 feet away. It's probably more correct. This is probably a U.S. example. So the nearest hole ID is shown, the distance, and pitch and roll information. Once they're on top of the hole and they hit the button to start drilling, here's what they see. They can see an actual visual representation of the bit, and the depth is currently shown. So as they start drilling, you can see here penetration rate is shown in like a gauge. And when they approach the target depth, the color indicates in green that they're basically within the acceptable tolerance of the target depth. And that's something that you can configure. In this case, it looks like they're slightly over by 0.2 feet, but that's good enough for based on the configuration that this mine has, and so it's showing on target. And when the bit gets close to on target, there's a beeping sound and alert to the operator to make sure that they're aware so that they don't go too far. Now, if they do go too far, there's a yellow blinking that starts to happen, and it basically warns the operator, tries to get their attention so that they know that they're over drilling, basically. All right. So that's and then after this, it goes back basically to navigation. So that's the basic drill cycle on the PTX for the operator. We've also got a utility I just wanted to mention in the desktop, on the desktop side. This is a screenshot of the desktop application within this utility called the Equipment Display Dashboard, which allows you to basically tile all the different ProVision units in one screen, and you can add a lot more than 6. It just kind of depends how much your monitor can fit here, but you can tile them all on here and resize them individually, and it gives you a kind of an at-a-glance status, in the field, what's going on for each unit. So it's nice for dispatchers or for mining engineers who are charged with keeping track of what's going on in the field. They can choose to see only drills if they happen to be interested in drills, or a mixture of any different type of ProVision units. But basically, they've got this visual indication of what's going on. All right. So it seems like I flew through that pretty quickly. It was really meant to be a kind of a short overview and an introduction to what we're trying to do with the drill system and what we've got available. So at this point, I'll open it up and see what kind of questions we've got, and hopefully I can answer any questions that you have.
So we have one that's rather common, I suspect. So how long might it take to install a ProVision drill system?
Yeah, so the time in order to install the system is kind of there's two parts to that. One is actual, getting the hardware on site. So there's as you would expect, a fair amount of hardware with the system. There's the screen, there's the GPS receiver and antennas and other cabling and so forth. And so we put all that together and we get it on site. Usually takes us about 3 months to for that lead time. The installation on site is relatively quick. It only takes about a day to do a hardware installation on a drill. It might be 2 days. It just kind of depends on availability of the machine and how many people are working on it. The installation of the server, if you've already got ProVision 3 server, it's just a little bit of configuration. But if you don't have any ProVision 3 at all, then obviously the server itself is going to take some time, some engineering time to install and to configure and to do some training and show your people both in the office and in the field how to operate the system. So it's a little bit variable, but it's usually done within a couple of weeks. Could be longer, just depends how many units you're working with.
Excellent. So we have a couple more here. How does drill energy index relate to the calculation of specific energy, or in other words, work done per volume of rock excavated/drilled? It seems to be the same thing.
Yeah, this may be just a mixture of terms on my part in the presentation. When I said drilling energy, what I meant is actually specific energy. The equation that we use to calculate is the specific energy equation. So it's using those sensor inputs that I was referring to, so I think we're talking about the same thing here.
Excellent. Final question: is hole data automatically composited for one hole, and can values for the first few feet of previously blasted subdrill be excised from the hole's average energy value?
So the way it works is, as the system is drilling, for every, if I remember right, we've got it set to every centimeter or two. I think it's every 2 centimeters. Every 2 centimeters of depth, we take a sample, basically, of these sensor outputs, and that data is saved. It's stored locally on the PTX, but it's also forwarded. I think the interval is a little bit. It's actually time-based. Every 5 seconds or so, an update is sent back to the central side, and so we keep. In as close to real time as possible, we're storing this information in a profile that's associated with each individual hole. So each hole will have kind of a specific energy versus depth, and then not just specific energy, we also store all the individual sensor values as well on the central side. So basically everything's there, and it can be referenced in the future and reported on, and you can do whatever you like with it. The second part of this question, values for the first few feet of previously blasted subdrill be excised from the hole's energy. Well, so I think this is, we don't actually do this in our calculation. We're not, we're providing you essentially with this profile, and so how you handle it is something that is completely up to you. And if you want to remove the first few feet of data, then it turns out to be a pretty easy thing, because we've got that as a function of depth. So basically you're free to apply. I have a feeling this is something that's going to kind of differ depending on the type of material that you're drilling, and probably something that's different from mine to mine. So that's something that you have the freedom to manage on your own.
Thank you, Bill. I think that does it for our questions. I apologize we went a little long, but we hope it was informative. If you have additional questions or comments, certainly don't hesitate to contact us. You see the email address there. It's products@mmsi.com. Thank you again for your time, and we hope to see you in one of our future webinars. Take care.
Thank you.